Today we're talking about angle-angle similarity postulate. Corresponding sides and angles are a pair of matching angles or sides that are in the same position or spot on two different shapes. For example, if you look here, the red angle mark at angle B and E means that they're both the exact same angles. Same with F and C, and same with A and D. If we look at the tick marks on these side lengths, those tell us that the sides are the exact same. Okay, so these are arc marks and these are tick marks, okay? So either the arc mark or the color is helpful. Sometimes you'll see me make the arc marks like this, and that's what we normally use when we don't have colors. So congruent triangles are going to have the exact same sides. So if you look here, and they're going to correspond. So angle 4 is corresponding with angle 4, and it's the same side length. If we rotated this shape right here, we would be able to see that angle 5 is in the same position as angle 5. Same with angle 7, with angle 7. This non-example shows, for example, angle 5 is the same length, but then all of a sudden we get angles 4 and 6 that are not the same. So these are not congruent. These triangles do not have corresponding sides at 4 and 6. This doesn't always work with angles, okay? Two triangles might have the same angles and they may be congruent, for example, these two, but notice that this one is slightly bigger. They still have the same exact angles, but the sides are not the same. So, for example, you could make this angle extended, or this triangle extended, and at this angle, they're still the same. At this angle, they're still the same, and at this angle, they're still the same, but the side lengths are definitely different. So, just because they have the same angles does not mean that they are congruent. These are what we call similar. Similar triangles have the same shape but different size. So, right angles are all similar. They have to also be proportionate, which means that they correspond and have the same angle ratios, or excuse me, same side ratios. For example, if we take 12 and we put it over 5 and we write it as a ratio, and we set it equal to the same number in the same position, 24, over 10, like in this one, they both simplify to be 2.4. If we did this for every angle, as I did down here for you, you will see that every single one simplifies to be the same ratio. So they all have the same sides. Now, it only works if you match up their corresponding sides. So I always like to label them or like circle them differently. So these two I underlined because they're in the same spot, and they're both in the middle of the 90 degrees. So I know angle 5 with side 10 and 5, and sides 13 and 26. So, similar versus congruent. Identify the shapes that are similar, congruent, or neither. Justify your answer and support it, okay? Take a second and I'll be back to show you what I did. All right, so here's what I did. In number 1, they are similar. They have the exact same shape. All the angles pair up together, they correspond, but if you look, they're different sizes. Okay, so they are similar, not congruent. In number 2, they're congruent. They have the exact same shape and the exact same size. If we look here, this angle is the same as this angle, and these two angles are also the same. And we have a 90-degree angle right here and right here. So their angles are the same. Their side lengths also match. So, for example, this side length with this side length, this side length with this side length, and this side length with this one. Number 3 is similar. They have the same exact angles in the same spots, but they have different side lengths. Angle 4 is congruent because all their angles are the same and their side lengths are also the same. Number 5 is neither. They don't even look alike at all. Number 6, if we look at these, they are similar, same shape, angles-wise, but different side lengths. So, the angle-angle similarity postulate. This postulate allows you to say that two triangles are similar even if you only know two pairs of angles. For example, in this one we only know K with Y and J with X. Well, the reason for this is because we can assume then that L and Z have to be the same because every triangle equals 180 degrees. So if these two add up together and give you this L angle, then these two add up together to give you Z. They have to be the same. So you don't need to compare all the side lengths and angles to show that two triangles are similar. You can just use the angle-angle similarity postulate. For example, you are given enough information to show that these two are similar. They're telling you that this angle right here is the same as this one. So angle RST is the same as RUV. They're both 48 degrees. You can also say that angle R is on both figures. So angle URV is the same as SRT. So we know angle R is congruent to angle R because they're reflexive angles. We have to state this. It's saying that this angle R in the big triangle is the same as angle R in the little triangle. So these are our two angles. So we can say, as long as we have these two pieces of information, that they are similar by the angle-angle postulate. So triangle URV is similar to triangle SRT by angle-angle postulate. All right, complete the statement. You try these 5 questions for me, and I'll be back in just a second to show you what I did. Okay, complete the statement. If two angles of one triangle are congruent to two angles of another triangle, then they are similar. Determine whether the triangles are similar. If they are similar, write a similarity statement. So in this one, you know, even though angle E is the same as angle H, angle F is not the same as angle C. So these are not similar. If we look at number 3, angle F is the same as angle H, and angle D is the same as angle G. Triangle EFD is similar to triangle J, and now you got to be careful. You got to start at the same one. So we started with E, so it's J, then we went to F, so it's H, then we go to D, so it's G. So triangle EFD similar to triangle JHG because of angle-angle. Down here, this one is also similar. Angle L is congruent to angle P because it's given at 85 degrees. Angle LMK is congruent to PMN because of vertical angles, like so. So we know two angles, so triangle LMK is similar to triangle PMN at angle-angle. If we look at number 5, it's also angle-angle. So angle R is congruent to angle S because they're given 90 degrees. Angle Q is congruent to angle Q because of reflexive. So triangle RQT is similar to triangle SQU because of angle-angle. And that's all I have for you, so I'll see you next time.